morning, children. In our last class, we had discussed IUPAC nomenclature of organic compounds. Now, let's go for the reactions of organic compounds. That means chemical reactions of organic compounds. Though there are millions of organic compounds, the reaction participated by organic compounds can be categorized into four different categories as combustion reaction, oxidation reaction, substitution reaction, and addition reactions. Now let's go in detail about these reactions. First one is combustion reaction. Already you are all familiar with the term combustion. Combustion reaction can be defined as a chemical reaction of a substance with oxygen resulting in release of heat and light energy. That means if a substance is reacting with oxygen and that reaction is associated with release of heat and light energy, then that reaction can be referred to as combustion reaction. So here organic substances like pure carbon in the form of coal or coke, hydrocarbons, in that hydrocarbons, alkanes, alkenes and alkynes will be there, hydrocarbons, and some carbon compounds like ethyl alcohol undergo combustion reaction to produce generally carbon dioxide, water vapor, and associated with release of heat and light energy. Now let's go for the discussion of these combustion reactions. See, a chemical reaction in which a substance react with oxygen and releases heat and light energy is called combustion reaction. In simple terms, it can be referred to as an exothermic oxidation reaction. An exothermic oxidation reaction can be referred to as combustion reactions. If you see examples, carbon on undergoing combustion to produce CO2 and produces heat and light energy. Generally, we're using coal for this reaction, and methane, which is the major component of CNG, that is compressed natural gas, undergo combustion to produce carbon dioxide, water, and releases heat and light energy. Butane, which is the major component of liquefied petroleum gas, which is most commonly used domestic fuel, on undergoing combustion produces CO2, H2O, and same as above, heat and light energy are released. You can balance this equation. 2C4H10 plus 13O2 gives rise to 872 plus 8CO2 plus 10H2O. Ethyl alcohol, C2H5OH, on undergoing combustion produces CO2, H2O, and as in the above, it produces heat and light energy. So once again, see, combustion reaction is a chemical reaction in which a substance reacts with oxygen and releases heat and light energy is called combustion reaction, or it can be simply defined as an exothermic oxidation reaction. Examples, carbon plus oxygen gives rise to CO2, producing heat and light energy. Methane in the form of compressed natural gas combined with oxygen results in formation of CO2 and 2H2O along with release of heat and light energy. Butane combined with oxygen to produce carbon dioxide, water vapor along with release of heat and light energy. Ethyl alcohol combined with oxygen producing carbon dioxide, water vapor, and along with release of heat and light energy. So here if you see, if this excessive oxygen is available, That means sufficient oxygen is available for combustion reaction. Only products include the carbon dioxide, water vapor. Carbon dioxide, water vapor. Carbon dioxide, water vapor. So other product, carbon monoxide also can be formed if supply of oxygen is limited. That means when an organic compound is undergoing combustion in the presence of limited supply of oxygen, carbon monoxide also can be formed along with CO2 and H2O. Then if we consider unsaturated hydrocarbons like alkenes and alkynes, due to the presence of double bond or triple bond in between two carbon atoms, they require high amount of energy for bond breaking. That means to break the double bond or triple bond, it requires more energy than in the case of single bond in alkanes. That's why alkenes and alkynes undergo combustion, but they undergo incomplete combustion. If they have to undergo complete combustion, they require the presence of oxygen rather than the presence of air. In the presence of air, even these saturated hydrocarbons undergo incomplete combustion. What is petrol? Major component of petrol? Octane. Major component of petrol is octane. That is used as fuel in light motor vehicles. Fuel is placed inside the tank and combustion chamber will be there. In that combustion chamber, as sufficient supply of oxygen is not there, a part of the fuel undergo incomplete combustion. That's why smoke is produced. Smoke is nothing but unburnt carbon particles. As supply of oxygen is not sufficient, they will be burning incompletely and resulting in release of smoke. So if alkenes or alkynes are to be undergoing combustion, they have to be mixed up with oxygen. Ethane or acetylene, when mixed with oxygen and ignited, it burns completely, producing huge amount of heat and light energy. That flame produced is referred to as oxyacetylene touch. The oxyacetylene touch is used for welding of metals as it produces temperatures around 3200 degrees Celsius. Okay, that's about combustion reactions. Next reaction is oxidation reaction. Oxidation reaction can be defined as a chemical reaction in which oxygen is added to a substance or hydrogen is removed from a substance. A reaction in which oxygen is added to a substance or hydrogen is removed from a substance is referred to as oxidation reaction. A reaction in which oxygen is added to a substance or hydrogen is removed from a substance is called oxidation reaction. That means this is quite similar to combustion reactions, but combustion should be exothermic. Oxidation can be either exothermic or endothermic. If oxidation is exothermic, then it is referred to as combustion. Okay, so here for carrying out that oxidation reaction, you will be requiring a chemical substance which is referred to as oxidizing agent or oxidant. Oxidizing agent or oxidant can be defined as a chemical substance that supply oxygen or removes hydrogen from a substance. A chemical substance that supply oxygen or remove hydrogen from a substance is referred to as oxidizing agent or oxidant. A chemical substance that supply oxygen or removes hydrogen is called oxidant or oxidizing agent. If you have a look at that example of oxidation reaction, ethyl alcohol, before going for example, we should discuss common examples of oxidizing agents used in organic reactions. In organic oxidation reactions, we will be using acidified K2Cr2O7 or alkaline KMnO4. Acidified potassium dichromate or alkaline potassium permanganate are used as common oxidizing agents in organic reactions. Acidified potassium dichromate solution will be in orange color and alkaline potassium permanganate solution will be in purple color. These can be used as oxidizing agents in organic oxidation reactions. Now let's go for examples. Ethyl alcohol CH3CH2OH. On treating with acidified potassium dichromate or alkaline potassium permanganate will get oxidized to ethanol in first step, and on further oxidation it will get oxidized to ethanoic acid. So see, CH3CH2OH on treating with acidified K2Cr2O7 or alkaline KMnO4, first it will get oxidized to CH3CHO, which is nothing but ethanol. This can be referred to as oxidation. Why? Because by removal of hydrogen from ethyl alcohol, it is getting converted to ethanol. That ethanol on further oxidation will get converted to CH3COOH, which is nothing but ethanoic acid. CH3CHO is getting added with oxygen to produce ethanoic acid, so it can be referred to as oxidation. This is very important concept with respect to your board exams or competitive exams like NTSC or PolyCET. Actually, it was given in this year PolyCET question. Ethyl alcohol on treating with acidified potassium dichromate or alkaline potassium permanganate produces substance X, which on further oxidation produces Y. What are these X and Y? X is ethanol and Y is ethanoic acid. As a matter of fact, this is a base. This reaction is the base for alcohol detectors to detect the person who is driving by drinking. So they will be changing their color. Acidified potassium dichromate on treating with alcohol will be changed to green in color, from orange to green. Alkaline potassium permanganate from purple color to colorless, it will be converted. Based on the quantity of K2Cr2O7 or KMnO4 undergoing change in color process, they will be detecting the person is in safe limits of alcohol or not. Okay, now let's go for substitution reactions. Substitution reactions. These reactions are quite similar to displacement reactions, which we had discussed in your first lesson, that is chemical reactions and equations. In case of organic compounds, substitution reaction can be defined as it is a chemical reaction in which one or more hydrogen atoms of alkane are substituted by any other reactive atom or group of atom under suitable conditions. These are the characteristic reactions of alkanes. Alkanes means paraffins, meaning less reactive. As tetravalency of carbon is completely satisfied by single bonds. As tetravalency of carbon is completely satisfied by single bonds in alkanes, they will participate in substitution reactions only. So substitution reaction can be defined as a reaction in which one or more hydrogen atoms, one or more hydrogen atoms of an alkane are substituted by any other reactive atom or group of atoms is called substitution reaction. These are the characteristics of alkanes. Alkanes participate in substitution reactions. If you consider an example, methane, which is CH4, on reacting with chlorine in presence of sunlight or any light. Normal light is also sufficient for the reaction to take place. Then chlorine atom replaces these hydrogen atoms one by one. First, one hydrogen atom is replaced, leading to the formation of CH3Cl and HCl. CH3Cl can be referred to as chloromethane. This is still having three hydrogen atoms that can be substituted. So CH3Cl further react with chlorine in presence of same conditions, that is in presence of sunlight or any light, produces another hydrogen atom is replaced, producing CH2Cl2 along with formation of HCl. This is referred to as dichloromethane. That dichloromethane is having still two hydrogen atoms that can be substituted. So, on further reaction with chlorine in presence of light energy, CH2Cl2 produces another hydrogen atom is replaced, leading to the formation of CHCl3 plus HCl. CH3L3 is nothing but chloroform, which is used as local anesthetic for the purpose of carrying out surgery in olden days. Nowadays, the uses of chloroform is restricted as an anesthetic due to the fact that it is found to be attacking onto the liver. Next, still it is having one hydrogen atom is to be replaced. CHCl3 plus Cl2 under the same conditions, it produces CCl4, which is carbon tetrachloride. It can be referred to as tetrachloromethane and carbon tetrachloride. So net reaction can be written as CH4 plus 4Cl2 gives rise to CCl4 plus 4HCl. That's a complete reaction. CH4 plus 4Cl2 gives rise to CCl4 plus 4HCl. That means for 1 mole of methane, if it is furnished with 4 moles of chlorine gas in presence of sunlight, the final products obtained are CCl4 and 4HCl. If quantity of chlorine is varying, products may be varied as discussed above. Next, coming to addition reactions. These are the characteristics of alkenes and alkynes, which are unsaturated hydrocarbons. These reactions can be defined as a chemical reaction in which an alkene or alkyne combine with hydrogen or chlorine under suitable conditions. That suitable condition is nothing but the presence of catalyst. A reaction in which alkene or alkyne add up with hydrogen or chlorine under suitable conditions is called addition reaction. For example, alkene, which is ethene C2H4, on reacting with hydrogen in the presence of catalyst produces C2H6, which is nothing but ethane. And if I consider ethane, C H triple bond CH, on combining with hydrogen in presence of catalyst, it produces CH2 double bond CH2, which is ethene. On further hydrogenation, it produces C2H6, which is ethane. That means here you can observe that unsaturation is loose, saturation is obtained. Unsaturation is loose and saturation is obtained due to this addition reaction. Addition reaction forms the base for hydrogenation of oils, vegetable oils to fats. Hydrogenation reaction is nothing but the process by which unsaturated oils are converted into saturated fats. Unsaturated oils are converted into saturated fats by reaction with hydrogen in the presence of catalysts like nickel or palladium. Okay, so for the hydrogenation of oils, I'll be using catalysts like nickel or palladium. Okay, thank you.